Thank you for your warm welcome, and thank you for inviting me to be here. I'm very happy to be here because this is where I grew up. Madras was my place where I was educated. So I'm back here, and I grew up as an automation engineer. I'm going to talk about automation as well. These are the people who work in this paper. Karyne, my colleague, myself, we are the Sociotechnical people in this project. And my friend Dikai, he's the professor of robotics. And Pratik Shreshta is the client who actually used our robots to build a 5-story timber building in Australia, in Perth. And that was the paper about. But because the time is very short, I'm not going to repeat what I have written in the paper. You can read it. But I'm going to tell you about what we have done past that paper and what we are doing now in UTS to promote the idea, get the construction people in Australia as well as the government to get interested in using automation in construction. Okay? So Industry 4, which came about, and we all talk about Industry 4, and then Construction 4 adopted Industry 4 to introduce technology. And what came about when robots were introduced in construction, that there was a feeling that you have to use the human-machine interface to develop. This was the feeling from DeSoto and others, and so requires social aspects of human robot. So let's talk about socio-technical system design. Socio-technical system started in the 1960s when I was studying in my university, and it started in the automation in the Volvo factory in Sweden by the Tavistock Institute. But in India, it actually came about when they introduced sewing machines to replace garment stitching in Ahmedabad. So since then, socio-technical systems have come along a long way. There were a lot of principles of socio-technical system, starting from Churns in 1987, Clegg in 2000, and recently Eason, who passed away recently in 2013. But there are 4 key principles which seem to be important for modern day socio-technical system. First thing is, when you build a system like an automation system, like a robot, don't build the whole thing fully. Implement only the minimum critical spec so that the system can evolve and the prototypes can be built and tried. The second thing is, don't wait for the system to be installed and then think about the social system, which was what was happening in the 1960s. Do them together. Try to build the social and technical aspect of the systems together. The third is, get the people who are involved, who actually use the system to participate. So it's co-value creation in social systems. And prepare for evolution of the solution. So the solution will not be perfect the first time you build it. And as you use it, you can evolve it. The current view of socio-technical system is that balance optimization, as everything is changing, the technology is changing, the nature of work is changing. So think about working in that constant change. And one of the things we talked about in the paper is using design thinking principles, which are becoming important as well. Okay. So this was the robot that we built for building that 5-story building. The robot, I think it drilled screws into the timber floor, 160,000 screws or something in three months, and it did precisely put the screws on the floor. Okay. And that then generated a lot of interest for us to do something. So in our paper, we thought about research questions was, how does innovative idea translate into practice? What roles do stakeholders play? So those were the research questions, and we used a single case study. So this was after we interviewed a lot of people, because post the installation, we did a lot of interview of the stakeholders. And then based on NBO analysis, which is the software for qualitative analysis, we actually developed a kind of a map of what was happening in the process. And we looked at the strategy, planning and organization, design and development testing, proof of concept, the media and labor union, all those aspects were developed in these nodes. Okay? So social life happens at the intersection of one or more stakeholders. This is what we found. And we found that at a particular time in a specific place, the intelligent robot that was ultimately deployed had to have a social interaction with the people. So this is one of the statements that why not make a wonderful, the way the whole idea started was they wanted to do a very innovative project, and they said, why not make a material readily available with automation? We are not robotic designers, not robotic expert. We don't even do robotic. This was the client who said that. Then they engaged UTSS to work with them to develop this robot. So what are the implications for research and practice from our work? Have an organizational view of human-robot system. We think that when you develop a robot, it's not a product. It's a product plus people plus the organization, because roles will change, responsibilities will change. So you have to think about the whole ecosystem, have a systemic view. As this morning, Professor, we had a wonderful talk this morning, and also about a systemic view. So think about the organizational view, the workflow, apply the socio-technical system principles, harness experts. We have to have experts from different disciplines, because construction is a very multidisciplinary topic. So you can't have one person telling us what to do. You have to think about using multidisciplinary. And be willing to change, and that's important, and learn to share knowledge. This is what we found from our research and practice. So now we have moved away from Industry 4 to Industry 5. And this is becoming a new area of research, and this is what we are looking at the moment. Because Industry 5 says technology is not enough. Technology should have a societal work, have a network, plans for operation. So from a point of Industry 5, we have to think about human centricity, which is one of the things that we do, sustainability, and resilience, mainly because of post-COVID, there is a lot of problems with supply chain, but generally resilience of the supply chain. So Industry 5 is expanding from Industry 4, and that gives us an opportunity to look at other aspects of robotics and in people, not only sustainability, we talked about waste and other things, and also resilience. How do you make the organization resilient? So just before I came, we actually demonstrated to the construction industry how humans and robots can work together. I do not have a video of it because I didn't know whether we have time. We actually tried to emulate these three human-robot collaborators. First thing we did was we had a robot taking a tile and giving it to a laborer, and the laborer was putting the tile on the floor. And to demonstrate that this can be done by a woman, we actually used a woman worker. She was one of our postdocs, to show that in Australia, inclusiveness is a big issue. So we actually asked a woman to put the tile down. The second one, which we demonstrated, was a robot going and helping somebody to put heavy object like a window on the sill, and it adjusts itself according to that person. Okay? Thank you. I'll be finished. And the last one was a fetch robot, which we actually went and painted as wall. Okay? So we showed three types of examples how humans and robots can work together. To use this robot, which is actually an autonomous robot, we developed an AI engine. I used ChatGPT. We actually put the socio-technical principles into the ChatGPT. And the ChatGPT acted as a supervisor, or we called it concierge. So it actually asked the robot to come in front of the wall and paint the wall. So we tried to demonstrate to the industry different ways of using robotics. Okay. That's it.
Thank you. Thank you. Thank you so much.